I'm Cameron Cedar, and I'm a technology strategist with SUSE. I focus on new technology, more importantly around Kubernetes and containers. And today I'm here with you, going to share with you some information about using Ceph storage for persistent storage on a Kubernetes platform. And we're going to talk about what we're trying to solve, some types of volumes, and what the CSI is. We're going to talk about SUSE Enterprise Storage, some of the prerequisites and setup of the storage, and then also dig into Rook and its prerequisites and the setup of Rook. And then afterwards, we'll go through a demonstration using the RBD and CephFS drivers in Kubernetes. So what are we trying to solve? Really, it's all about the disk storage and the fact that by default in containers, it is ephemeral, which means it's going to present with us a couple of problems. Since it's ephemeral, the storage will go away anytime that container crashes, or if you have a kubelet within Kubernetes that restarts, that storage is typically going to go away. And those files that are in that storage will be lost, and your container is going to start as a clean slate. Secondly, when you run containers together in a pod, you might need to be able to share those files between those containers. And so we're going to help solve those problems by going through the storage drivers that are required for Ceph storage to be able to solve this problem. So some of the types of volumes that are available, we have standard storage volumes, and then we have some open source volumes that we can use, such as NFS. We can use the RBD drivers, CephFS. Since Kubernetes being around from version 1 on, clear on up to around version 1.9, there was a lot of integrated drivers, such as host path and local and NFS, that were really used for a lot of testing. And then there were some third-party drivers that you could attach, and they had their own way of attaching those. And now we have different types of volumes, and you can go out and search for those various third parties through NetApp and EMC, Portworx, even LinStore has their DRBD drivers from Linbit. And then we have our cloud service providers that also provide drivers specifically for the stack that they run on as well, from Azure and Google Compute and AWS. So what is the CSI? It's the Container Storage Interface. And that container storage interface, in a nutshell, is a standard interface to expose storage to your container workload. And it was designed so that third-party providers could provide their own level of storage, and we could have a common infrastructure that we could use to interface with the Kubernetes environment. And everything could be all common, have common feature sets that we program those into the Kubernetes environment. So that actually all started out in version 1.9, and there's quite a few of those drivers available today where they actually have achieved the generally available status, where a lot of the features are readily available and supported. Most of them are available in version 1.18 of Kubernetes. There's quite a few of them that are new. There's a link here on that you'll see that will show you a lot of the drivers that are available. And then also I've got a link there available for the Ceph CSI driver, and that actually includes the Rados block device layer and CephFS. So some of the typical driver features that you might see in the CSI throughout all the various drivers that you might see available from third parties and localized drivers in Kubernetes. Some of those driver features are specifically for secrets and credentials, raw block volumes, skip attach is another feature, pod info, expansion for file system drivers, and then other types of data sources such as snapshotting and cloning, attaching and reattaching snapshots, volume limits for quotas, and also ephemeral. And then along with that, you'll see a fair number of different sidecar containers that go along with these drivers. So when you install your CSI driver, along with that, you'll get provisioners, attachers. These all come as containers that basically interface with Kubernetes to provide the level of storage that you need for your pods. More importantly, when we look at Ceph CSI, we have a support matrix for that. And this is actually listed in the driver GitHub. If we look at the plugin for the Rados block device, it has a number of features that are available. And some of those features are still in beta or alpha stage. Then you'll notice that some of those are in the generally available feature status. And it shows when those actually came out in what Kubernetes version and what Ceph cluster version those actually work with as well. Additionally, with CephFS, the same thing. It's got its whole feature set and the status and what Kubernetes version those came out in. Those are constantly being updated on their GitHub repository, which shows the Ceph CSI support matrix. So SUSE Enterprise Storage, if you're using that for your Ceph storage cluster, you don't have to if you have one already existing. It's the same process that applies. But you need to install some software on each one of your Kubernetes nodes as a prerequisite. Typically, the Ceph common package needs to be installed. That is a common package between all Linux distributions if you're using Ceph. And then the XFS progs package as well. Along with that, you'll need to configure your Kubernetes cluster to communicate with the Ceph cluster. So that might mean that you would need to architect it in such a way that your Ceph cluster can reach your Kubernetes cluster. So if that be the front-end network on your Ceph cluster or the back-end network, whatever that might be to get the best performance, that's the way that you'll need to architect that. And then, of course, making sure that those can connect to all your monitor nodes, your OSD nodes, and the metadata if you're using CephFS in your cluster. And then, of course, provisioning your RBD pools and your CephFS volumes will need to take place. Now, if you're using SUSE Enterprise Storage, that's all taken care of by default. And you'll need to also set up a CephFS volume if you're using the CephFS plugin for Kubernetes. For the Ceph Rados block device setup, now this goes beyond the prerequisites. Now, when we're setting up the driver, there's several things that we will need to do. And these setup instructions will require you to create several text files. These text files are in a markup language called YAML. So you'll need to create these. These are specific for Kubernetes. You'll need to create a config map that is a mapping of the CSI driver for Ceph, and more specifically for the Rados block device. And that will actually prepare the system to set up the sidecar containers for that driver. And after that, you need to create your Rados block device secret. Now, the secret is something that you can utilize either your admin key within Ceph storage, or if you're creating another user in your CephX platform, you could create an RBD user for that and use that key and inject it into Kubernetes. But this will all need to be taken care of in a specialized YAML file for creating a secret key in Kubernetes. Once that's completed, then you create a Ceph CSI plugin. This plugin is also, again, the specialized YAML text file. Once you create that plugin, it will then create the provisioner and the other sidecar containers. Once that's created, you can now utilize those sidecars by creating a storage class specifically for the Rados block device. That again is YAML formatted file, and once the storage class is created, then you can create a persistent volume claim. The persistent volume claim can be taken care of in your pod creation. You could have it all in one single file, or you can create it in individual files. That is your preference. Again, it's going to be another text file that you create. Once that's created, then you create the file that is utilized for creating your pod that utilizes your persistent volume claim. It seems like a lot of steps, and it really is a lot of files that you have to create in order to get this up and running. Here is a sample of what the storage class might look like in a YAML format. These are typically really small files. There's not a lot to them, but there's a lot of specific information in there, especially relating to the drivers. But let's say you want to make that really quick. And this is the method that I actually prefer, just because for the simple fact that I don't have to go in and recreate all those files all the time, which isn't typically the funnest thing in the world when it comes to being a Kubernetes administrator or operator. You get used to a lot of YAML files. Helm charts can allow you to do this in a really quick and easy method. And I've included a link to the Helm chart, the Ceph CSI RBD Helm chart. All you need to do is fill out a values YAML file, and there's just a few modifications you need to make to it. That values file already comes with the Helm chart. So once you pull down the Helm chart, that file is there. You edit the Helm chart or that values file, include all the information required for connecting to your Ceph storage. So it's going to ask for all of the IP addresses for your monitor nodes, and then of course the ports that it will access them on. And then you execute the Helm install command. And you'll typically use the namespace switch in the command and a name, and then point it towards where the CSI driver is located. And that's going to set up and install your sidecar containers, the snapshotter, the attacher, the provisioner, and the registrar. Those will all get set up and created all automatically. You'll have a storage class all created for you. Everything that you saw previously will all be done in automated fashion. So it's pretty quick setup. Additionally, CephFS, if you're going to use this to share your file system across multiple containers in a pod, this is something that you would absolutely want to use. Creating the CephFS CSI plugin, this is all done again in YAML files that you'll need to create. You'll need to create the storage class, the persistent volume claim again, similar steps as you went through with the Rados block device plugin. Again, make it easy on yourself. Use the Helm chart. Do the quick setup. Download it. You set up the values YAML file, and then execute the Helm install command with the minimal amount of switches, and you're ready to go. It will take just a couple of minutes to set up and a few minutes to install all of the sidecar containers, and you're up and running with CephFS storage in your cluster. Additionally, if you're running your Kubernetes cluster and you would like to install Ceph using Rook, you absolutely can, and you have that flexibility. SUSE Enterprise Storage provides that flexibility. Today, it is offered as a technical preview. And here's some of the prerequisites that you might require. It does require at least 3 worker nodes. And you would also need 1 extra disk on each one of those worker nodes that can be utilized as a Ceph storage disk. And then, of course, installing the SUSE Rook manifests, which come as part of the media in SUSE Enterprise Storage on your Kubernetes management node. And then, of course, running through all the steps to set up Rook Ceph cluster on Kubernetes. Additionally, there's not a whole lot of steps extra. There are a few YAML files that you would need to format and prepare. But along with that, it's mostly just setting up some YAML files, doing a kube control create or a kube control install on a couple of other items there. So there's not a whole lot that has to be done. Most of those files are already manually created for you to get Rook up and running. Additionally, for Rook, when you're setting up the RBD and CephFS drivers, again, it's back to those same commands as you had before, and it's similar files. I'm going to share with you a link in a further slide that I have available at the end called References that will show you some basics for those files. And I'll show you some in the demo as well. But creating the pool and the file system required for Rook will need to be done because Rook does not automatically set up the pools that are required. So you'll need to create a metadata pool and a data pool for CephFS. You'll need to create a data pool for RBD. And then, of course, a file system will need to be created for CephFS as well. And then if storage classes for both of those will need to be manually created. And then, of course, your persistent volume claim for your pod. And that's pretty typical for executing and setting up a pod. Pretty similar process, but it is shortened and it doesn't take quite as long as a standard SUSE Enterprise Storage setup. So now I'm going to switch into showing you a demo of setting up and utilizing Rados block device plugin and CephFS plugin on Kubernetes. All right, let's get started with the demo. Let me just tell you what I'm running this demo on, and so you kind of understand what the lay of the land is. I have a small cluster here. It's running on a bunch of virtual machines. I have 5 worker nodes. I've got 3 masters, and so it's pretty small. On top of that, I've got a bunch of pods running that are all part of the Kubernetes system. And then I've got a bunch of pods for Rook. As you'll see, if we pull up and run kube control get pods, look at all namespaces, you'll notice that there's a bunch of stuff for Rook, all the OSDs. I've got extra disks for each one of the worker nodes for the Rook OSDs. And then I've got the RBD plugin, the CephFS plugin, and that's kind of where we're going to be focusing on today. So to get started, let's look at our storage classes because those have already been already set up in this environment. If I look at a kube control get SC, that'll show us our storage classes. I've got a couple of them there. I've got an NFS client, I have the Ceph block, and then the CephFS. The default one is set to Ceph block, and you can swap that default around however you like. I want to take a look at a couple of YAML files that have been used to configure this environment. So let's go ahead and go over to a directory here that has some of that in here. I want to look at the storage class that was used to create the block device storage class. So if you take a look at that, it's pretty easy to understand. There's a number of things in there that when you take a look at the configuration for a standard Ceph cluster versus running it with Rook. Rook has drivers that attach directly to the CSI, and it makes it a little bit easier, although it's really not too much different. In this particular case, it's creating a pool called replica pool, and it's got an image format set to 2. RBD can set different types of defaults there. And then of course, it's enabled the layering feature for RBD. And it's pretty simple. Once the storage class is set up, then it will make calls to the driver, which in turn will create a persistent volume for your containers. So let's go ahead and take a look at that. In fact, we've got some examples. I wanted to take a look at a MySQL and a WordPress. Let's take a look at the WordPress as an example here, because this has got some added pieces into it, because it's going to create the persistent volume claim for you. You'll notice that it's got a persistent volume claim name, and then it's tying that to an app called WordPress. Notice how it's also calling out the storage class, which is Rook Ceph block, which was the same storage class name that came from the storage class configuration that we were looking at. And we're requesting for 20 gigabytes in this particular volume claim. If you scroll further down in this file, you'll notice for the container itself, when you configure the container under the container spec, you'll notice a couple of things there on the volume mount and the volume itself. Notice it's got the persistent volume claim, and it's calling that same name that we were looking at earlier. And then the volume mount and its location under var www.html. And we'll see that when it mounts up when the application is started. So let's go ahead and do that. We'll go ahead and apply. And we'll do MySQL. And it'll take a couple of minutes for it to come back, because this is such a, a loaded environment for a demonstration. There we go. There's a couple of them that came back unchanged because those volume claims had already been created before. But you notice that the deployments for the application, those were created for WordPress and the MySQL. And if we do a kube control get pods for the namespace default, which is where it put it in there, it's creating the container. So this will take a few minutes for it to actually come up. But once the MySQL database is up and running, and the WordPress will connect to it, and it will also be running. So one depends on the other. So one will keep restarting until it's basically ready. So they're both running now. We'll see if they'll actually connect together. In order for us to actually do some introspection into that that pod, we can actually do an exec command into that pod. Let's take a look at WordPress, and we can do a command like mount, and we'll kick back the mount command that was used. Notice you can see dev RBD0 on var www HTML as ext4. And the same with your MySQL. You can see it's mounted at var lib MySQL. Let's show some CephFS. CephFS is slightly different. It's a file system. It's not a block layer. First, I want to show you the storage class for CephFS. If we take a look at that, it's not much different than what we saw earlier with the Rados block device. Notice how the provisioner is different. We're pointing the provisioner to the rook ceph CephFS as the provisioner, but everything else is fairly similar. Notice that there's a couple of things that are new. Is actually creating a file system name, MyFS. That's actually going to create the metadata pool within Ceph. And then the MyFS data 0 is going to create the data pool within Ceph. And those are going to be used for CephFS. So some good things to keep track of there. And then all that's at the bottom is all the secrets, the secret keys that are used for Ceph. And that's storage class. Now let's take a look at the test web server I have set up here. This web server, same concept as we looked at with the last application that was running. This one also, we're going to gather a persistent volume claim, but this time we're pointing to the CephFS persistent volume claim. Now, the storage class is also different. It's the rook CephFS, and we're requesting for 1 GB on this file system. Now, if we scroll down a little bit further, we can look at the application data and what specs we have in there for the container. So we've got the volume mount, and the volume is being pointed back to that persistent volume claim, and the mount of where that volume claim will be mounted is at var lib www HTML. So let's go ahead and control create test web server, I'll go ahead and create this application. CephFS demo created. There's a couple of things that already exist, which is the persistent volume claim and the web server services, which is fine. Since I had already been testing it before, I didn't go back and delete those. At any rate, when we take a look at the pods, we can see, let's see, WordPress is still in a crash loop there for whatever reason. CephFS demo is our web server. It's an Nginx web server. Let's do some introspection on it and take a look at what we got going there. Control exec. We want to swap this out. CephFS demo. And we want to look for, how about that? And there is our CephFS. Notice it's actually pointing to all of the monitor nodes. That's what these IP addresses are and their ports. And it's pulling out that volume ID. That's the persistent volume claim that we requested. And it is mounting it on varlib www.html. And so that's pretty easy. So that shows that we are able to provision two different storage classes, one for Rados block device layer and one for CephFS. And both of those storage classes can be mounted, volumes can be claimed and mounted within containers and running on Kubernetes. And here are some references from what you've seen and I've talked about in this session. You can use these references to recreate any bit of this in your environment. There is the CAS platform documentation for SUSE enterprise storage integration, which can also be used for other Ceph storage as well. There's also the Rook Ceph storage technical preview that you can utilize to set up your Rook on top of Kubernetes. And then some more documents that are very helpful is going out to the upstream Rook documents to actually get all of the YAML files that might be required that you can modify. And then also to have a further understanding of your Ceph CSI driver as well. I've included those upstream documents. So I hope you enjoy this. I hope that you can utilize this to in your environment to attach Ceph storage to your Kubernetes cluster. Hope you enjoy that and have a lot of fun. Thanks.